They said you wouldn't make it so far.
Are you interested in finding a school to enhance your education? Not sure where to start? Well, today your search is over. CDP Maths Lab eSchool offers classes for CSEC, CAPE, and GSET subjects, along with training in early childhood education and data operation. Listen to what CDP Maths Lab students have to say about their most fulfilling experience.
While I was attending, it was almost the best experience I ever had. Like I was in class, but I wasn't. I would give the school the full 10 out of 10 because the teachers take the opportunity to help the ones that really needed it. To the upcoming students, this is the best decision you have made and it will benefit you in the near future.
Talk to your soul and say, I can.
CDP Maths Lab eSchool was founded by Ronique Bernard in August 2009 with a vision to see our students receive a solid education with an emphasis on developing their cognitive skills. The school is committed to developing individuals who will have a positive impact on the society.
The class it really helped me, and if you are going to see CSEC, I really recommend this class, so you could always give it a try. The prices are really reasonable, and it is really worth it for online class. Like myself, you would be.
Okay, good afternoon. Sorry, rather good evening. Good evening again, Tangini. Good evening again, Lexi. And good evening to our viewers on YouTube. Last week we had visitors joining our marathon online in Zoom. And so today is our final preparation day before the exams. This evening we'll be looking at the January 2021 past paper. So we'll be looking at majority of the questions. We'll be looking at the 7 questions in section 1, or section A rather, section 1. And we're looking at the vectors and matrices in section 2. And if there's time, we will look on the other optional questions. All right, so as usual, we do our devotions before we start our classes. And since we have to do devotions, I mean, you can't do anything without the Creator, without God, without the Almighty God. And so we must give God all the honor and praise. So let us get into our devotion. And today is July 5th. So of course, I will be sharing our scriptural meditation from the book of Proverbs. It says, "My son, attend unto my wisdom, and bow thine ear to my understanding." So God is saying that we should attend to his wisdom. He's also saying to us that we should listen to his understanding, that thou mayest regard discretion, and that thy lips may keep knowledge. So there's a relationship between knowledge and discretion with attending to God's wisdom and his understanding. Verse 3 says, "For the lips of a strange woman drop as an honeycomb, and her mouth is smoother than oil. But her end is bitter as wormwood, sharp as a two-edged sword. Her feet go down to death. Her steps take hold on hell. Lest thou shouldest ponder the path of life, her ways are movable, that thou canst not know them. Hear me now, therefore, O ye children, and depart not from the words of my mouth." Now, the message you can garner from this passage of scripture is simple. God is simply saying to us, do not depart from his words. Read the Bible, which is the word of God. Apply it in your lives, and you will not be trapped by the devil and his snares or his tricks. Follow the word of God. If you have not yet started to do so, start today and throughout the rest of your lives. So we're going to listen to our theme song, and then we're going to pray, and then we're going to begin. And I'll pray today.
You know, there's so many promises in the Bible that we can hold on to. So when you're feeling down, you're feeling low, just remember, he's made promises. Listen to this one. He said, I will never leave you nor forsake you. So you see, when the bills need to be paid and you don't know where the school fee is coming from, am I speaking to somebody in this place today? Let me tell you something. When the grades don't look right, remember, God can still turn it around. He can change your situation. Hallelujah. Silver or gold, or that you would never feed the fire or shiver in the cold. But I did say that you never walk through this world alone. And I did say, don't make this world your home.
right, so let us pray. Good night to Daniel. All right, good night. And good night, Stacyan. Good night. Also, Stacyan is joining us from YouTube. All right, so let us pray. And at this point, it's all in one person's hands, and that is God. You have to trust him. You know, God says, in all thy ways, acknowledge him. He says, lean not unto thine own understanding. You might feel as if you're not that yet prepared, but you have done your part. You have done what you can do. Leave the rest to God. Leave the rest to God. So let us pray. Let us pray. Almighty God, who art in heaven, hallowed be your name, dear Father. You are God. You are our creator. You know us from before we were conceived in our mother's womb. Lord, you have made a promise in Jeremiah 29, verse 11. And I pray that you'll forgive us now, dear Lord, of our sins that we have trespassed against you, as we forgive those who have trespassed against us. And so, Almighty God, I just want to present to you before you know, dear God, every student across the Caribbean, not just Jamaica, not just CDP Landscape Services, but every student, those who have studied, those who have practiced, those who have done their best in preparation. And Lord God, you alone can make this a success for them. And so there's nothing hard for you to do. You know where they are. You know what their abilities are. You have given them these abilities. And I pray that, dear Lord, as they put their trust in you, do not disappoint them, dear Father. Pray that you'll glorify your name tomorrow in their language exam. Glorify your name in their mathematics exam, dear Father. And I pray that when they should get the results, they will remember this prayer and remember that you answered their prayers. And so, Father, because of our faith in you, we are giving you thanks for answering our prayers. In Jesus' name we pray. Amen. So, folks, be blessed. Be blessed. And so now we're going to move into our
there's so many promises in
not this one. Oh, like, seriously? Our January 2021 past paper. Let's listen to our little music math song and then get cracking.
Sing with me. Come and join our mathematics class. Surely you will enjoy being here with us. Sing with me.
All right, so it's now time to turn to, and students in Zoom, good evening, Daniel, good evening, yes, Nikita Williams, and of
Hi, sir.
course, yes, good evening. Welcome back to CDP Lazarus Services. All right, so we want to get into the January 2021. God is good, isn't he? Get your hands on this, eh? All right. Please do not take forever to do the question, please. I beg of thee, do not take forever to do the question. All right. And good night to those persons who are watching us live on YouTube. I would ask that you share the link with your friends and family who are doing exams tomorrow. Please do not be selfish. So share the link with others. And if you're watching us for the first time, and the subscription button, I guess you have heard this regularly on different platforms. If your subscription button is still red, it means that you did not subscribe. We'll be returning to our HSB classes this week, Wednesday, God's willing, in preparation for those persons who are doing exams next week, Wednesday. All right, everybody finished doing question number one, part one. Remember, we're not 10 in the whole day and listen. All right. So please ensure to go through it quickly. Otherwise, you'd have wasted your time, not getting the opportunity to go through as much questions. I think that is division there. Check about this pass with here. I think it's division. Looks like addition. Maybe it's addition and not division. It looks division-ish. Let me. That looks like addition, right?
Yes, sir.
Okay, so it's addition. So where is the duster? All right, so I want to go through the question now. You should have finished that already. It says use in calculator. So of course, I'm going to switch to my video, my camera. I'm going to go directly to the board. All right. Everybody see the board clearly?
Yes, sir.
Okay. So it says 1 4/7. Why am I not seeing this properly? 1 second. Okay, better now. It says 1 4/7. 1 4/7. 1 second here. Let me put this over here. Back to this. 1 second. Yes, 1 4/7 plus 2/3 minus 1 5/6. Now, my style as usual, well, of course, I add in 2/3 to this. So, well, let's show you a shorter method now. It's exam time. 4/7 plus 2/3. The shorter method is that you can multiply, use this numerator, denominator rather, to multiply this numerator, and you get 3/4 12. Use this one to multiply with that, 7 2s 14, and then you multiply across. Good. So you're going to end up with, that's what, 26 over 21. And once the numerator is greater than the denominator, it is obviously that there's an extra whole. There's an extra one whole in that. So this can be written as 1, let's put it down here, equal to 1 and 5 21s. Good. And we already have a one whole right here already. So 1 plus 1 is 2. So when you add that to the extra 1 that was already there, you're going to get 2 and 5 21s. So 2 and 5 21s right there. All right, so Lexi gave me an answer already. Okay, so we're going to subtract this from the 2 and 5 21s. So good. So we have already add this already. So we're now going to subtract this from what we got. So let's write this smaller. Now, naturally, 1 from 2 will give us 1. And I showed you that before, that it's possible to subtract to compute the whole numbers first, right? So 1 from 2 is 1. And we have 5 21s minus 5 sixths. Now, we can find you have an equivalent fraction for this and for this, where both of them are the same denominator. In your case, you talk about lowest common multiple, and lowest common multiple for both of them is it's basically, all right, what I could do here in this case as well is turn this one whole into 21 over 21, add it to the 5 sixths. 521 first, that is, and then minus 5 6 from it. So what we can get here is 26 over 21 minus 5 6. And I know that the lowest common multiple for 21 and 6 is 42. Am I correct? 2 ones 2, 2 twos 4. 42, 7 6 is 42. Good. So then now I can rewrite this as 2 times this will give us what? 52 over 42 minus 35 over 42. Because 7 5 is 35. And then 35 from 52. Can somebody do the maths and tell me what that is, please? Are you seeing the board now, Stacy? What is 35 from 52? Come, folks. Come. Anybody heard me a while ago?
17.
17. So that Lexi, that can't write. Not at this time, Lexi. What you doing? What you doing? That's the answer right there. That is the answer right there for number 1A. So you see where you went wrong, Lexi? Lexi, see where you went wrong?
No, sir.
Huh?
No, sir.
What is it? No?
No, sir.
You say you not pay attention to me, Lexi?
Oh, yes, sir. I see it.
You're sure you see where I went wrong? Where you went wrong?
Yes,
Oh,
sir.
yeah, you're to add the 2/3 to the 1 4/7 first. And then you'd have gotten this 26/21. And they subtract 1 5/6 from it. And they have that subtract this one from that. You left with this. Then I rewrite this to like this, which I end up with this, that from that. And then when you do that, and that's the answer. All right.
Okay.
All right. People, Amar doing exam Tuesday? It's just for the person doing exam, you know. Is she doing exam Tuesday?
No, sir.
No, we're not going to accept her this evening, all right? This is for you guys tonight, please. Okay? So please to communicate to her that I'm only accepting students who are doing exams this week. All right, so we're gonna go to the second part of the question. All right, let's go now to the second part of the question. So it says write the value of 7 cube of 27 divided by the square of 9 square rather as a fraction in the lowest term. Quickly, see if you can do that quickly, please. And don't take forever. It must be written as a fraction in its lowest term. Let me know if you have an answer, if you have an answer already. All right, can I continue now? You guys have an answer already? All right, I see the answer in the chat. Okay, Daniel gave an answer. All right, so Daniel has given an answer. So let's go through it now then. That's how we're going to do it. All right, so let's go to the board. Now you have to know what this means. This is simply asking you to find the cube root of 27. And the cube root of 27 is what? What's the cube root of 27?
3.
3. And what's 9 square equal to? 81. But they said that it should be written, Lexi, in its lowest term. So one way of doing this, let me show you the secret. If you write this cube, this is the same thing as well, yeah, cube root of it is 3. You have to leave it at that, right? And then you have 9 times 9. So what you can do to make it, yes, Lex is correct. So an easy thing to do is to cancel this. 3 into 7 goes 1 time. 3 into 9 goes 3 times. And therefore, it's now equal to 1 over 3 times 9, 27. Easy calculation. So make, instead of writing 81, you can just write 9 times 9, do your cancellation, and bam, you get your answer. All right. So we're going to move on now to our other question. So we're doing the January 2021. That's what we're doing now, January 2021. All right, so now we're going to go into this question now. Can somebody read that question for me, please?
The, thi- the thickness of one sheet of cardboard is given as 485 times 10 to the negative second power millimeter. A construction worker uses 75 sheets of cardboard stacked together to insulate a wall. Show the exact thickness of the insulation is 363.75 millimeters.
Okay. One question. One second. All right, so the thickness of one sheet of cardboard is given as 485 times 10 to the negative 2 millimeters. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. Show that the exact thickness of the installation is 363.75 millimeter. Try it and see how you could do it.
Sir,
Okay, you finish?
yes, sir.
All right. But we don't get the answer yet. All right, I've seen good evening, Captain Silt. Hi, sir. Can you please go through the 60 topics like explain them? All right, will do. Will do, will do, will do, will do, will do, will do. Well, that's what we're going through step by step. All right. Okay. Now, so what answer you come up with, Lexi? Lexi, what
So the
answer you came
same
up with?
answer with the on the paper.
Okay, how did you calculate it? How you calculated it? Tell me what you did.
The first one I got the 485 times 10 to the 19
Uh-huh.
second power. Then I
Uh-huh.
got 4.85. Then I multiply it by the 75 sheets.
Okay, well done. Well done. Good job. Good job. All right, so for those persons who are viewing on YouTube, I'm going to show you now how it is done. For those persons who are just coming on our channel, we are actually doing the January 2021 past paper. So I will explain as we go along. So we're on the computation part of the exam now. That's Captain. Let me know if you're hearing me. All right. Okay. So one sheet is equal to 485 times 10 to the negative 2 millimeters. Now, you have to know what 10 to the negative 2 millimeters mean. Good? Now, 10 to the negative 2 means 1 over 10 square or 1 over 100. You might be asking, how we get that 1, sir? Well, know this, that once an exponent is with a negative power, you're going to put 1 over that, whatever the power is. All right, just know that. Just remember that. All right, so now we can calculate 485 times 1 over 100. This is basically saying to us that this now is then equals to 485 divided by 100, and that would be equal to 4.85 millimeters. So the thickness of one sheet is 4.85 millimeters. And they have given you 75 sheets stuck together. Now you have to know what the word stuck, or the term stuck together mean. They are piling each sheet on top of each other. Good? So therefore, 4.85 times 75, the number of sheets, will give you the answer. All right, let's see, your brain will work good. That's nice. Very good.
Sir,
Come again?
sir,
What was
what did
that?
you say?
I said, that's nice. Your brain is working very good. You know, I'm telling you, your brain will work good. And keep it up. Make sure
Yes.
you continue, make sure your brain continue working good.
Alright.
Mhm. All right, so Stacy, I hope you saw your mistake. Stacy, you saw your mistake. 4.85 times 75 will give us back 363.75. So well done, Lexi. Good. So when they ask to show that, they are simply asking you to do the calculation, which you must end up back with the actual answer. All right. So let us now get back to our question. So we're going to go back to our worksheet. Right? All right, so let's go back to it. And that's one more. Now, you should write the thickness of the insulation correct to two significant figures. So what's the answer? Correct two significant figures. Write the thickness of the insulation correct to two significant figures. Just give me an answer quick and fast. Bubbling like that. Quick and fast. That's easy. That is easy. First, you have to ask yourself the question, what is the thickness of the insulation? And of course, you are given that. So that's why it's easy. So write it correct to two significant figures. So what this question actually cover, Captain. Captain, could you give me a real name, please? What's your real name, Captain? I don't know that name. Give me a real name. Yes. So it is covering significant figures. It covers standard form. And if you know how to express standard form with a negative integer as the exponent or a positive integer as the exponent. So they looked at that as well. Good. So that is exactly what was being tested right there. Good. So once you're able to do the multiplication, it simply meant that you understood what the exponent meant, 10 to the negative 2. That is exactly what they are testing for. All right. All right. Anybody have an answer for this? Correct to two significant figures? Anybody have an answer for it? Does anyone have an answer for this? This shouldn't be taking so long, students. Come on. Does anybody have an answer for this? You can unmute your mic and answer and I go faster, all right? All right, so Tangini gave me that answer. All right, so that will be correct, Tangini, but ensure to put the 0 on it for the placeholder, all right? Okay, Tangini.
Yes, sir.
All right, so we're going to go quickly to the question again. So it says the thickness was 363.75 millimeters. And they ask us to write it in the two significant figures. So you have to actually recognize that all of these digits are significant figures, but the first two are 3 and 6. So you cannot just write 3 and 6. Reason being, the value is not 36. It is within the 300s. So you put the 0 for placeholder, and this would be the answer. All right. All right, so let's move on. And students, to save time, you need to if you don't type that fast, you need to just unmute your mic and answer, please. You cannot sit and wait for the answer, right? All right. So write the same one correct to one decimal place. So you're there examining your knowledge of decimal place, significant figures, standard form. So what is the answer correct to one decimal place now? The same thickness, What is it correct to 1 decimal, please? Come, quickly give me the answer. I don't see nobody giving me any answer in YouTube chat. Yeah, what's the answer? Lexi, go ahead. Was that Lexi or Daniel? Daniel, go ahead, Daniel.
300.
How much?
300.
I'm not hearing you.
Oh, never mind. Wait, me and look again.
362.8.
The same thickness correct to 1 decimal place. Persons who are watching on YouTube, you are free to give your answer in the YouTube chat. And if it's the first time you are, you can make your contribution to our platform by just subscribing. Doesn't cost anything. So just subscribe. And if you like the class, you click on that thumbs up button. All right. And please to share this link with your friends who are doing exams. All right, any answers, please? Correct to 1 decimal place, the same thickness, 363.75. Any answers?
362.8.
Curious to know. Now take forever to answer one question.
Sir Lexia answer or somebody answer. But we can't
Okay,
hear
what's the answer? I'm not hearing it. I have to talk up so I can hear.
Sir, 362.8.
362 or 363? You mean
3.
363.8?
Yes, sir.
That is correct. 363.8. That is correct. Okay, well done, ma'am. All right, so the same thickness is what they're now asking us to write to 1 decimal place, which is different from significant figures. So we have to look at it. It's now at 2 decimal places, but we need 1 decimal place. So it's 363.8. But why 0.8? Because according to the rules, if the number after the first decimal point, decimal place rather, is 5 or greater than 5, you add 1 to the number in front. Good? You add 1 to the number in front. And then simple. That is the answer. Let's now move on to our next question. And folks, don't go into the PPM exam to take forever to answer them questions. Yeah. Don't do it. And then, wow, they are testing us on everything. They are testing us on everything. Wow, this is a beautiful topic. This is a beautiful past paper. They are testing us on everything. So just a reminder for you, the number that you are writing in standard form is 363.75. This number must be written in standard form. Quickly write that number in standard form, please. Persons in the YouTube, on your YouTube platform can, of course, put your answers in the chat and I will respond to tell you if you are correct. So you're asked to write that same thickness in standard form. So you're asked to write it in significant figures. You're asked to write it in decimal place, and now you're being asked to write it in standard form. Any answers as yet? You're supposed to look at it and tell me, you know. You're supposed to just look for the answer and tell me. I can't believe when I take for a answer this, honestly. Any answers yet?
So, well, my test is
The longer the take for go through, the longer the time it will take for go through the past paper. I keep telling you that. Still not working, man. Still not working. Now it's 7:19 and we're still not past question number 1 yet. Come on, man. Don't do that. All right, now take a while. Can't wait. Students, I'm trying to give you a chance to do the question on your own first. You cannot be taking so long on a simple question. There's nothing to calculate right there, so than to apply the rule. You're supposed to look at the thing and give me the answer. Lexi, what is the answer? Unmute your mic and answer, please. Lexi?
I didn't get it.
What you did not get?
The answer.
What do you mean you get the answer? What are you talking about? You're supposed to write the same thickness in standard form. Tangini? Tangini?
Yes, sir.
What is the answer?
Sir, 363 point.
When you're writing a number in standard form, what are you supposed to do?
So place the decimal point between the first 2 and 0 digits to make it a
Exactly,
standard.
Lexi. So you mean you tell me so you don't get it, Lexi. Or you must tell me so you don't get it. Honestly. Honestly, Lexi. How you must tell me that?
Yeah, because when we calculate it,
But Lexi, there's nothing. Lexi, there's nothing to calculate. What is there to calculate? What is there to calculate? There's nothing there to calculate, Lexi. There's nothing there to calculate. What are you calculating? Can't believe it, man. Honestly. What is there to calculate? Honestly, what is there to calculate? Tell me, what is there to calculate? What use is there to calculate? Huh?
yeah, because usually when you do that, then you would have multiplied to see if you get back the answer.
Lexi, the first thing you do is apply the knowledge where you have. You know what to do, you do it. Do you understand that?
Yes, sir.
You have to have confidence in yourself, man. Come on. You're correct, Stacy. Simple apply the rule. You know, so you must move the decimal point between the first 2 non-zero digits. Apply the rule. Once you're applying the rule, you cannot go wrong. But because you're not confident, stop doubting yourself. If you're going to be in my class, you cannot doubt yourself. So you have to move it between the first 2 non-zero digits. Then you write times 10. And the number of times you move the decimal point, 2 times. That's it. Nothing more. You can't spend a whole day what are you calculating? Let's move on. Come on, man. Because you're doubting yourself, man. Students, if you're going to doubt yourself, you're not going to make it tonight. You're not going to make it. Doubting yourself does not work. It doesn't work. Now let's go. Read this one for me, please. Anyone? Can somebody unmute the mic and read the question for me, please?
Marco is on vacation in the Caribbean. He changes 4,500 Mexican pesos to Eastern Caribbean dollars. He receives 360 Eastern Caribbean dollars. Complete the statement below about the exchange rate.
Okay, thank you. Now let me tell you what we're gonna do. We're not working. Keep your pen. Don't put your pencils down. We're gonna be talking out the question. We're talking through the question. Now, first of all, which topic is this question based on? Which topic in the syllabus is this question based on?
Consumer arithmetic.
That's the unit, but which topic?
So foreign exchange.
Foreign exchange. That is what I want from Alexi. Be confident. Be confident. You can do it, you know. You can do it. So I tell you, I don't want you to do no maths tomorrow. Just relax tomorrow. Do not do any maths tomorrow. Just relax. Pick up your Bible and read it, and that's it. All right. You don't need to do the maths tomorrow. So it is foreign exchange. No, so they ask us to find the exchange rate. Okay. So how would you approach a question like this? How would you approach a question like this? Anybody want to approach it? It looks kind of difficult, but it's not. I gave you guys a technique you can use when approaching a question like this. When you're doing any questions at all. I gave you a technique. What is it that I teach you to do when you're doing a worded problem? What's the first thing you're supposed to do? Your mic is muted, Lexi.
Read it in English.
Well, it is in English, but it is already in English. Yeah, go again, Lexi.
Is what they give you.
I don't. What you said?
You see what they give you.
All right. So how what do we do? What's the first step? We're gonna write down what they write down information. What given? Good.
Yes, sir.
So we must write down information given. Now, now remember that, and for the benefit of everybody else, hope you have seen the question. It says Marco is on vacation in the Caribbean. Yeah, sorry about that. So it changes 4,500 Mexican pesos to Eastern Caribbean dollars. Good. So this is how I would approach it. And me showing you how I would approach it, students, I have to give you a chance. Because when you get into the exam, You have to think for yourself. You know what I mean? So the first thing you get from the question is that 4,500, and let's put let's put the Mexican dollar before the currency there. 2, and he receives 630 Eastern Caribbean dollars. And they want to know the exchange rate. Now, let me ask a question using your common sense. Lexi, now me know you're thinking. Now me know you're thinking. That is what I want. Be confident. You must divide because it obviously what? Reduced. It obviously reduced. Right? Now, which of the currencies would have been the stronger dollar? The Mexican or the Eastern Caribbean dollar? Which one? Which one is the stronger one? Eastern Caribbean or the Mexican pesos?
So the Eastern Caribbean.
Eastern. So we want to find what one of them costs. Now you set up your this, even though it is foreign exchange, it is also based on ratio and proportion. See what's going on here? It's also based on ratio and proportion. Because if I could have written it like this, and you are being asked now to write it in simplest terms. And then you are left with now 450 to 63. So therefore you have to divide that now, right? Good. So it will divide, but stick to this part of it first. So you can do this now. So we're at, where are we now? 1 times that. So you can have 630 times x. It equals to 4,500. And x therefore is equals to 4,500 divided by 630. And therefore x is equal to what? What is x equal to? $7.14. Well, our this is 7 Mexican pesos and 14 cents. Therefore, the exchange rate is 1 Eastern dollar is equal to $7 and 7 Mexican, whatever them pronounce it as, Good. That's it. So you came up with a technique that you're supposed to divide, and you got the answer. Excellent. That's all I want you to think. Don't dare and think. Use your brain. I tell you already, apply yourself and you'll get there. Apply yourself and you'll get there. All right? Just apply yourself and you will get there. Okay? All right. So let's get to the rest of the question now. So you see what works for you when you talk it out? Yes, your brain click. So you look, seems like you're an auditory learner. So you have to see there. See, let me even set it up first. Let me even tell what I want to do. Set it up for you. Good to go. 1 mark. All right, let's move on now. Question number 2. Your favorite question. Your favorite question. All right, so we're at question number 2A. We're going to talk this thing through now. We're going to talk it through. Can somebody volunteer to read the question, please?
12. Factorize the following expression completely. 12n square minus 4mn.
Okay. All right. 12n square minus 4mn. Okay. So what do you want to tell me how to go through it? Somebody can tell me what to do? Explain to Mr. Bernard, what should I do? Don't be afraid.
You go find multiple of 4 and 12. Multiple? Yeah.
Multiple? No.
Highest common factor, sir.
Highest common factor. Good. Highest common factor. Remember when you're factorizing, you're finding factor. Highest common factor. Good. So what I could have done here, as I tell you in one of the class, I could write 3 times 4. Different ways you could write it. You could be that 4 is a factor. I would say 3 times 4 times n minus 2. Well, let's keep, you could use a prime factorization method. Let's use a prime factorization method, right? The prime factorization method would be 3 times 2 times 2 times n minus 2 times 2. Space, pardon me. Let me, oh, you see, you guys don't realize you're not seeing my camera. All right, let's go. We're going to use a prime factorization method on this now. Good, let's go. So the prime numbers are 3 times 2 times 2 times n times n. Good. Minus, minus 2 times 2 times n times n, m times n rather. So you look into both expressions now, and you find common expressions. Now I see a pair of 2 here, and I see a pair of 2 here. I see an n, and I see an n. So I'm going to divide both expressions by what is common. So the pair of 2 is common, and an n is common. So divide both sides by the same thing. Good. Prime factorization I'm using. Now, so now you're going to divide, and in cancel me divide, as you know. Good. Bop, 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 bop. So whatever is left, and note whatever you divide by, you're going to put it outside of your bracket. So we simplified it by 4n. 2 times 2, 4 times n, so it's 4n. So outside of my bracket, I'm going to put 4n. Good. And what is left is 3n. Then no, again, cancel, they can cancel. Bam, 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 bam. What is left is m. And that is your answer.
Sir, this supposed to have negative 1 m.
Negative 1
M.
m.
Right, sir.
Negative 1 mn. Well, you do the
4
same
in
thing.
4 in bracket 3 n negative 1 m. So you still right?
4n bracket.
Same thing what you
3n.
have, sir. Only thing you have one in front of the m.
Right here, sir? Oh, well, yeah, it's all right, but you don't need a one before it because you know it's still one M. But if you have it, fine, but you don't need it in front of it. I don't want to kill you for that. The more I got said, the more I chuckle and say, no, say, him not need the one. But it will still be correct because one M is M. 1 times 2 is how much? Devon, 1 times 2 is how much?
2, sir.
Just answer the man that show you something. 1 times 2
2,
is how
sir.
much? Huh?
2, sir. 2.
1 times 3.
3, sir.
1 times 4.
4.
So the pattern I tell you say 1 times the number is the same number. So 1 times M is M. Get it now?
Yes, sir.
All right, cool. And I test the knowledge now as a pattern more you catch. You follow? All right. Now, so that is the answer for the question. All right. That's the answer for the question. So I show you a technique. The technique that I'm showing you when it comes to factorization, this type of question is basically what you're supposed to do. You can use a prime factorization method and separate them and much easier and faster. All right. You might be asking the question now, what if I had a difference of 2 squares? Now, let's look at a difference of 2 squares question. Now, if I add 9 minus 4n square. Now, this is different. 3 times 3 is 9 minus 2 times 2 times n times n. In this case now, there's nothing common. But what you can do is take a 3 from this. Good. A 2n from that. You bracket it. Take the next 3. And take a positive 2n. And that is it. So I took a 3. It's not 2, you know, but the 2n go together. The 2n to your negative. Next one is positive. Take a 3, like a positive 2n. And that is that. All right. Stacy, you would have to use the playback technique for the video. I can't go back over that. You are watching from YouTube, remember. All right, so let's move on to our other question. And they are looking at the show that now. All right, before going no further, let's see other questions when we like. All right, let's see. All right, so that is okay. So we're gonna go now to show that. Can somebody read that for me, please? Can somebody volunteer and read that for me, please?
Show that x divided by 1 minus x minus 4x is equal to x multiplied by 4x minus 3 divided by 1x.
Okay. All right. Good. What does 4x mean again? What does 4x mean again?
4 times x.
4 times x. All right. No. So, first of all, what does it look like to you? What it looks like? What does the expression look like to you? What does the expression looks like to you? Anybody? All right, I will call names. It's Matthias. What does the expression looks like to you? When you're doing the show that, bear in mind that you cover up the answer. Cover it up. Ignore that. That's what we're focusing on. What does that look like to you now? What does it remind you of? People, what it look like to you? No, 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 no. Look good pan it and tell me what it look like to you. I didn't ask you what it is, no? Ask you what it looks like. All right, anybody want to tell her what it looks like? Does anybody want to say to Daniel what it looks like? What it reminds you of? Yeah, go ahead, Lexi.
So I'm guessing.
Yes, man, guess.
So when we're finding x,
Hold on 1 second there. My sincere apologies. Yes, anybody want to tell me what it looks like to you? All right, tell you what, to make life easier, for you, this is what you're going to do. You see where the X is? Just put a number. Just put a number for it. Just put a number for it. Any number. Somebody give me a number. All right, give me a number for the value X.
6.
What was it? Just give me any number, I'm afraid.
6.
Huh?
6.
6? Boy, we could tell yourself, you give me a smaller number than that, man.
2 then, sir.
2. All right, let's use the number 2. All right, so let's involve those on YouTube. All right. So we must show that this is equal to 4x minus 3 bracket, sorry, x must be right here, divided by 1 minus x. Now, I said to you, just give this x a number. Just give it a number. So you said 2. So wherever x is, I'm going to put 2. All right. Then 1 minus 2, 4, 2. So this would be 2 negative 1 minus 8. What does it now look like to you now? Still look like nothing yet? You don't look like, you don't remind you of nothing yet? What does it look like to you? Anybody? Daniel?
A fraction, sir.
Yes, Devon?
A fraction, sir.
Tell them again, Devon. What it look like? Devon, I'm never here. Tell them again.
A fraction,
A
sir.
fraction. You know, sister, you have one line, there's a fraction. Once you have a line, it must look like a fraction, people. Seriously?
Boy, so you make life hard. You know something for something specific.
No.
Oh, more than that.
No, but Daniel, I said, just tell me where it look like. I will remind you.
We can better say nobody in here never did and think that until not too long.
Anybody I think that either.
They look like a fraction. The first thing you should pick up is that you have one bar there, and you have a number above, a number bottom. Remember, you know, this is a number and this is a number. It is just as it's expressed this way. Because I can express the number 5. Look at this now. I can express the number 5 several ways. I can express this 5 several ways. I can express that 6 minus 1, 2 plus 3, 5 times 1, 5 plus 0, 7 minus 2, several ways. But they are still 5. So it's a number same way. Tangini, tell me what is on your mind. Likewise, Facebook said, what's on your mind? Tell me what's on your mind. All right. So first thing you have to always ask yourself, what does it look like? Ounce. A long time I don't see ounce. All right. Well, it didn't ask to find the value of x though. It simply asks to show that this is equal to that. So let's go through it. So because it looks like a fraction, we're going to treat it like a fraction. You see? Treat it like a fraction. That's the bottom line. It looks like it, treat it like it. Right? So 1 times x will give us x. This times that will give us 4x times 1 minus x, put it in bracket. And then you multiply this by that. 1 times anything is still the same, so you write that. So now, simplify when I reach at the top. So we're going to simplify that. So you have to do the multiplication for 4x times that is that. So we have x minus 4x, and 4x minus that will give you, well, voila. Let me make some space. Need a bigger board. Need a bigger board. Who's going to sponsor me a bigger board? Anybody? Any sponsors? So that's minus 4x over 1. So we're multiplying this by that. Multiplying this by that, we get x. This by this. we get negative 4x, and then put it in brackets, 1 minus x over 1 minus x. So we have to simplify now. So I use the distributive law and multiply that by that and that by that. All right. So when it's x, so negative 4x and then positive 4x. No, x squared rather. Good. Now we're going to, we can simplify this, good? And that becomes negative 3x. Can I erase what's at the top? So I can get some space. So we're going to move from here and go up. So follow me now. This from this is going to give me negative 3x plus 4x squared. Good. Now we are not through yet because we need to factorize this. We need to factorize this. We need to factorize this. So x is what is common. So we take out the x, and we are left with minus 3 plus 4x. Now, you might say, sir, that doesn't look like it. Of course, because I can rewrite this in the bracket and say x with the positive 4x here instead, and the minus 3 here instead. And I have care about my 1 minus x. I'm going to get my answer. So what are the principles involved in this? The principles involved in this is you treating the thing like a fraction, work it like a fraction, simplification of algebraic expressions, distributive law, factorization. You simplify again, then factorization leads it to your answer. So if you know how to do all of that, just simple apply yourself. Apply yourself. All right? Just simple apply yourself. Don't worry about nothing. Just simply apply yourself. And you will not go wrong. All right? So first thing, you look at it and say, what does it look like? If it looks like a fraction, treat it like a fraction. And you apply yourself. So make sure that you understand that distributive property is good. Then ensure just you know to do your grouping, your simplifying, and your factorization. Bam, get your answer. All right. Let's move on to our next question. Now, they are saying, hence solve. They are saying to us, and the question continues, hence solve the equation. Hence solve the equation. How do you approach that question? Just tell me how do you approach it? How do you approach that question? How do you approach it? How do you approach that question? Any ideas? Students in my class, whether right or wrong, still talk, because here's opportunity to test your skills. Don't sit there and wonder if what sir I look for, if that's right. Because you go back with the same with the exam. I don't want to go into the exam with that. Test yourself. Come, tell me, how would you approach it?
So you treat it like fraction.
All right.
They
Okay.
maybe put it 4x over 1 or so.
With the 4x over 1. But you lead back with the same thing. You'd end up back with the same thing, right? But go ahead.
Yeah.
Anybody else? You'd end up back with the x bracket so on. So you end up back with the same thing. So you don't write back what they gave you, good? And then what else would you do after that? What else would you do after that? What looks the easiest way to do it, by the way? Do you see an easier way to do this?
Never even know.
You don't know? Sure. You don't see an easy way to do it? Nobody doesn't say an easier way to do it. Well, x is certainly not 1. If you use 2.
X over 0.
Huh?
Yeah, x over 0.
No, it would not. Well, could be, you know. Could be, because 0 divided by 1 is 0. No, it would not be. If x is 0, then 0 from 0 is 0. X could be 0. X could be 0, yes. Could be 0. X could be 0. All right, let's do it together. I guess this one I bust in the brain, eh? All right. If x is 0, we're gonna try your idea, Daniel. There's an n solve equation, eh? So if x is 0, we'll just argue for argument's sake. Then you'd have end up with 0 over 1, because 0 from 1 is 1, minus 4 times 0. So therefore, 0 divided by 1 is how much? What is 0 divided by 1?
0 can divide by 1.
Of course, 0 can divide by 1. 0 divided by 1 is 0.
A 0.
And 4 times 0 is what? 0.
0.
0 minus 0 is 0. Yeah, you see? See it now? You just guess it, man. Just guess it. You understand? Just guess it. You see? That never hard. 0 must be the answer. All right. Let's see if we could do it another way. So you say you could guess it, you could just choose a value, plug it in, and see if we get back the answer. Yeah? Or let's try if we work it. Yeah? Let's see if we get the same answer. All right. So we could also add the 4x to both sides. We'll try that too. With the CDP labs, where we experiment. Good. We could do that as well. And then, because this now, you know, has to be equal to 4x. So you have 4x minus 4x gives 0. So what we could do here now is say, carry this to this side. Right. We could do that. Also, x now is equal to 4x times 1 minus x. Good. Okay. We're coming to come. No worry yourself. Fret not thyself. And then you can, let's come up here. So if we have x is equal to 4x, blah, blah, blah. So x is also equal to 4x minus 4x squared. Good. Now, we can carry over this x now. We can carry back over that x now and minus x from both sides. So you're going to end up with 4x minus x minus 4x squared. So it looks like a quadratic expression now, right? So x from 4x will give me what? 3x minus 4x squared. We can factorize this now. And if I factorize this now, I'm going to end up with, remember, it's still equal to 0. So I can factorize this now and say that x bracket 3 minus 4x is equal to 0. Now we know that one of the values of x is 0. Is it so? Let's see. Yes, one of the values of x is 0 because x is equal to 0. That's one of the values of x. But there's another value of x too. So we set this, we say x is equal to 0. I will find what this now is equal to as well. So can I, all right, let's follow my line. Follow my line. I'm going to go there. So now I'm going to say now 3 minus 4x is also equal to 0. So I can say now that 3 is equals to 4x and x is equals to 3/4. So there are two values of x. X is also equal to 0 and it's also equal to 3/4. So what I'm really doing now, them set you up to do a quadratic, to solve a quadratic expression. That's what I'm doing. I'm set you up to do that. And let's test both answers. Let's test. We know that x is also 0. That goes without saying. But the other value is 3/4. And let's see if that is correct. Can I erase this part? Remember, it is on YouTube, so just in
Yes,
case.
sir.
Yeah, all right. So we're going to test the answer now. We'll test the answer now. So we know x is equal to 0. That is one of our answers for sure. For sure. Let's test the 3/4 now. So if x is 3/4, we're going to substitute. We substitute. X is 3/4 divided by 1 minus 3/4 minus 4 times 3/4 boy, it's like I could go around the world to find an answer, don't it? No. You understand? Asleep, Lexi? It can't take too long to give me the answer then for number 1. Now 3/4 from 1 is a quarter. So 3/4 divided by a quarter minus, now 4 times 3/4 is 3. So this is a division. So we're going to work out that first. And you're going to multiply by 4/1, blam, blam. So we get 3. And 3 minus 3 equal to 0. So 2 answers are correct. 2 answers are correct. 3/4 and 0. All right. I see Mr. Eddie Plus is there. Yes, Mr. Foster. They can join us, Mr. Foster. You want to join us? Sir Foster, would you like to join us, sir? Oh, in the ear me, in the ear me, in the ear me. All right, so Foster, a show go on. All right, so we're going to erase this that is on the board. So this is students have to just apply yourself here. Don't make the expression make you feel jumpy. Don't be afraid. Take a deep breath. Let's take a deep breath and then you do your thing. Take a deep breath. Good. Mr. Foster is there doing them with us. All right. Now, can somebody read that one for me, please? Can somebody read that one for me, please?
Make V the subject of the formula. V equals square root of 5 plus VL. That?
Yeah, read it again. Make V the subject of the formula where P is equal to that. All right, good. Good. All right, give me a second. I'm going to put Mr. Foster in our class. All right, just give me a little second there. 1 little second, please. All right, just give me a second there. No, that's 1 second there. In the meantime, while I'm getting Mr. Foster up and ready to join our class, just going to ask for please to try and get it, try and see if we can figure it out in the meantime. Oh, mom, send it to that number. We're trying to go to 9:30 Foster, 9:30. All right, so Mr. Foster is about to join us. So let us continue until he joins us. All right, so it says make V the subject of the formula. All right. Now, my question to you, what's the first thing you should do with this? What's the first thing you should do with this? Come, students.
And square root or whatever, I guess.
Square root of both sides. Good. Makes sense.
So what?
Find the square root of both sides. Makes sense.
If you want scan to the square root and a square, I got square it.
Yes. Good.
So I think I got to substitute number for the letter.
Oh well, if it didn't have a clue, then naturally, if it didn't have a clue, if it didn't have a clue, you substitute. You know, so Lexi, if it didn't have a clue, I would have jolly well tried to substitute, of course. But since you have a clue, they were nice. Right, ma'am? Since you have a clue. If you never have a clue, then you'd have to go substitute. All right. So now we're going to continue now. All right, so Ruben boss said we must find V. What time it will end, Mr. Owens? We're trying to end at 9:30 and hopefully 10 the latest so you guys can get some sleep for language. If anything, I have to go against my rule and we have an early class tomorrow, early maths class tomorrow to wrap it up. So to wrap it up.
Like early what time?
Very early. What time are you supposed to get to home? Nobody's supposed to reach home no later than 4 o'clock. All right, so let's get to the camera now. All right, let's get to the camera now. All right, let's get to the camera. I'm trying to minimize this thing. All right, so let's get to the camera now. Let's go. Ready? Are we ready now?
Yes, sir.
Good. So P is equal to, everybody see the full board? 5 plus VT. And you know once you get rid of this, you have to square both sides, right? I want to square this. You're going to get back what's underneath the symbol. Then you must what? Make V the subject. So V is the subject. So V is the subject. All right, so Ruben answered it already. Okay, Mr. Owens, about 5. So Mr. Owens at 5. So we can bounce it at 5 o'clock. Hopefully. So P squared is equal to 5 plus VT. So now we can know we can know you guys in the full board?
Yes, sir.
Okay. Well, Mr. Ruben, same get an answer. Let's go save him right. So I love to rewrite this thing. All right, so we can say P square carry the 5 minus 5 and equal VT. And this is multiply. So remember, what we'll call it again? When you reverse, reverse thinking, right? The reverse thinking is saying that we divide this by V and this by V. Sorry, by T rather. So we'll divide by T. We're left with V. So V is therefore equal to P squared minus 5 divided by T. Oh, I don't also get minus 5, Mr. Ruben. Okay, Ounce, so your Ounce is from St. Kitts and Nevis, by the way. Okay, welcome to Jamaica, sir. Welcome to Jamaica. Nice having you. So what time is it now in St. Kitts? What time is it now in St. Kitts? Tell me what time it is in St. Kitts now. So we can know what time is best for you. All right, so we want to move on to our other question. This one is the real deal. Come now, want some confidence now. Confidence time. Ready? Already now? Just relax. Just want you guys to relax. Take a deep breath. Take a deep breath. It's 9:17, so you're 1 hour. Okay, so if we start at 4, it's good for you for 5. All right, no problem. That's what you were saying. All right, so let's go back to our screen. Let's go back to our screen now. And Ruben is from St. Vincent. Welcome, welcome to Jamaica. Welcome to CDP Labs of the Service, Ruben. Welcome. So we have somebody from St. Kitts. We have somebody from We have somebody from St. Kitts, and we have somebody from, all right, give me a second there, please. And from St. Vincent. Welcome, gentlemen. Just give me 1 second, please. I'm trying to get Mr. Foster on. All right. Mr. Foster will definitely take you through some other questions quick and fast. That's why I'm getting him into the system. When I take a long while, he moves lightning speed. Efficiently, that is. So let me just give him the information that he needs to get in. That is 88. All right, so everybody take a deep breath now. Take a deep breath. Take a deep breath. Okay. All right. Take a deep breath now. Everybody take a deep breath. Come, work with me. Take a deep breath.
Yes, sir.
Hold it. Take a deep breath. Hold on. Take a deep breath and hold it. For 4. 1, 2, 3, 4. Let it out. Take the next deep breath again. Hold it for 4. Let it out. All right. So anytime you get nervous, students, the best thing to do when you get nervous is to take a deep breath and get relaxed. All right. Okay. All right. So go ahead now and read that question on the screen. Anybody?
Repeat.
Could you read the question on the screen for Mr. Bernard, please?
The distance needed to
Read
stop
that
a
question
car.
on the screen.
Sir,
Yeah, go ahead. I'm listening. Go ahead.
the distance needed to stop a car, B, varies directly as the square of the speed S at which is traveling. At which it is traveling. A car traveling at the speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour?
Okay. All right. What would be the first thing you think you need to do? All right. How would you, what would be the thing, the first thing you need to do to make this question easy for you to do? What's a natural thing? What would you do to make it easy for you to do? What would you do to make it easy for you to do? Anyone? What would you do to make this question easy for you to do?
Read it in English and try draw a model.
Try draw, exactly. But it is already in English now. So you don't need to read it in English again. It's already in English. Or else you're going to read it properly in English. So it is already in English, right? So you want to convert from English now to algebraic statements. Make sense now? So if it is given in English, you can rewrite it now in algebraic statement. Am I making sense? Are you following me? You guys following me?
Yes, sir.
All right. So it's already in English. So we're gonna rewrite it now using algebraic statements. So let's get down to that. Huh? So it says the distance needed to stop a car, D. So they call that distance D. So let's go to my board and I'll show you what to do. All right. All right. So it says the distance needed to stop a car, D. So we're going to call it D. Good. 1 second. Oh, it's 891. All right. Now, so it says the distance needed to stop a car, D. So we want to find D, right? D. D. So D is the distance. D is equals to distance. I will need this distance to stop the car. Now, that D varies. That D, and Mr. Foster is on now. Mr. Foster is on. So let's wait till he joins us. Yes, sir, Foster. Sir Foster? Yes, yes, Sir Foster. Welcome. So Mr. Foster is from EduPlus. Brother Foster. He's from EduPlus. So persons who are watching from our live stream can also go to Mr. Foster's live stream as well and subscribe to his channel. All right. So we're both, you have two math teachers in this class. You are so blessed. All right, Mr. Foster, do you have the January 21 papers yet? Sir Foster?
Yeah, man. Hold on, can you hear me?
Yeah, I can hear you. Yeah.
You have the paper and just give me a second. See, my daughter is here. She can. By the way, is she? Can you hear her? Can you hear her right here? Because I hope she's not disturbing you guys.
No, I'm not hearing her clearly, but I'm hearing you clearly.
All right. So once you can hear me clearly, that's the most important.
Yeah, man.
Yeah, man. I have the January 2021.
Okay, so we're at page 9, which is question number 2D, the final part of question number 2.
Let me get it up in my special app here. You know?
All right. So I'm going to show you an approach. Mr. Foster will show you another approach. All right. So looking at the question again. So the distance D. Now they are saying that distance varies directly as varies. Now it says varies directly, and the word varies comes from the word vary, which means to change. So the length of D changes as the square of the speed, S. So D varies directly as the square of the speed S. That's what that means. At which it is traveling. So the square, so this, when the speed is actually squared, it affects the distance D. Now, so we have a car now traveling at a speed. So you have to break down the information according to what is given first. Good. So you don't have to reread everything again. Now, they say a car is traveling at a speed. So here's our car. Maybe it's a Porsche or a Lamborghini. All right.
Sir, that is no Porsche or Lamborghini.
Well, the CDP loves Porsche now. You want to buy it? It is a rare one. I've never seen this before, right? All right. So this car is traveling at a speed of 70 kilometers. So the speed of the car is 70 kilometers per hour. That what that means, you know. That means that for every hour, the car covers 70 kilometers. Now, it says a car traveling at the speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. So it needs a distance of 40 meters to make a stop. All right. Now, first of all, what is wrong with the question? Let's say if you're thinking. What is wrong with the question? Anything wrong with the question? Let me put the piece of information. Requires a distance. That requires a distance of 40 meters to make a stop.
So when you say half of the board?
Was in half of the board?
Half.
See the full thing now?
Yes, sir.
Hold on.
No, sir.
See the full thing now?
Yes, sir.
Much better?
Yes, sir.
All right, good. So let's start back again. So the distance D need to stop a car. Distance D need to stop a car. So this is the D we want to find. For the question, what distance is required to stop a car traveling at 80 kilometers per hour? So they are saying those that D varies directly as S. And we're seeing here that the speed of a car, this car is traveling at a speed of 70 kilometers per hour and requires a distance of 40 meters to make a stop. What needs to be changed in this question? To make it easier. My question to you, what is easy? No, what is needed to do with this question, first of all, to make it easier to work with? Any answers? Are there any questions that you'd like us to answer, first of all? No questions? Somebody said no?
No, sir. You can't see about the board.
Sorry. My apologies. There any questions? No questions at all? What about the question that you understand? What about the question that you don't understand? Hmm? Anybody?
No, sir.
All right. Now, first of all, what does this statement mean? That should have been one of your questions. All right. Owen says that I did not see the question, but I am assuming we have the distance and speed. All right. Yes, they give us a distance, a required distance and speed. But we need to find, all right, to find the question, Ounce, just kind of play back, capture it, and then you come forward. All right. Yeah, but what does D varies directly? I see your answer, Devon. So respond to it. But that could not be the answer, Devon, because they're asking for what distance. So that couldn't be the answer. What does varies directly mean? What does varies directly mean? Anybody knows?
So change according to the speed, sir.
All right. But how would we write a formula for that to illustrate this principle? Anybody have an idea? All right, let me show you. Now, varies directly is the same thing as direct variation. This is the mean as the same thing as direct variation, which can be written as y is equals to k times x. Now, k is a constant. K is a constant. Y is an dependent variable and x is an independent variable. Now, my question to you, which of these two is dependent or independent? Note, y is our dependent variable, while x is our independent variable. So my question to you now is, which of these two variables is dependent, which is independent? Now, with your answer, give your explanation. Hmm? Oh, that one go? Where's it, Daniel? Didn't hear that one. Don't know. Sir Foster, you there? Sir Foster? What? Say I go on?
Oh, sorry, I don't think first of all, I was supposed to press my mic. Not the video. See me there, walk on.
Yeah. You want to guide them on this one?
Want to guide them on this one? Alright, start allow me to share my screen. First, a good night, people.
the name is Mr. Foster, so it's nice to meet you all. It's probably some of you probably would have probably been here when I was here a few weeks ago. Alright. For the persons on YouTube, good night to you guys as well.
Music loud, Foster. Music loud.
Alright, Rashina, turn it down. Give me the remote, baby. It's right here. So I said, keep my daughter right here, and she stop being right beside me. So just turn that on. So is that better now?
Yeah, man, that's better, man.
All right, ready.
So, yeah, we're at page number.
Yeah, man, we're good, man. We're right here. So.
Okay, then.
All right, so this is the question that we're doing, right? All right,
yes,
so
that's the question. Yeah.
So the distance needed to stop a car D varies directly as the square of the speed is at which it is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? All right, so how do we do this question here now? As you can see over here, this question is based on direct variation, right? So the question says D varies directly as the square of M. So by just using that right there, we know that this is direct variation. Right. And so once you get a question based on direct variation, this is the formula that you're going to be using. So y is equal to kx. It says d varies directly as, so that means that d is going to be the subject. So y varies directly as x. This is the way how we write it. So if d varies directly as the square of the speed s, all we're going to do now is that we're going to take the same formula right here. All right, so our same formula right here. But we are going to substitute into this formula the values that we were given right here. All right. So can somebody tell me what are we going to substitute the y for? All right. So what am I going to replace the y with? Am I going to replace the y with the d, or am I going to replace the y with the s? The d. All right. Then so we're going to replace the y with the d. So let's do that now. All right. So if I replace the y with the d, it's going to be d is equal to what? K times what? K times what? What do they say d varies directly as?
The square of the speed.
The square of the speed is, and so how am I going to represent that? How would I represent that now? All right, it's going to be s what? The square of the speed is, so it's going to be s what? I never heard that.
S squared.
S squared. All right, so it's going to be s squared. All right, then cool. Let's now go back to the question here. It then says that a car traveling at a speed of 70 requires a distance of 40. So in the formula right here, there are three things that we're given. We're given d, we're given s, well, s squared there, and we're given k. All right, you see in the formula here, you know what k is called? K is called the constant. So you see k here, k is called the constant, and that is extremely important. All right, but when we look in what we're given right here, let me get back my marker and highlight it. What are the two things that we're given? All right, so based on our formula here, what are the two things that we're given right here that we can then put into the formula?
Distance and the speed.
The distance and the speed. All right, the distance and the speed. And if we put the distance and the speed into the formula, what are we going to realize that we do not know? So we have to realize that we don't know. Did you just say k? I'm assuming that that's what you said, the k, right?
Sure.
All right. All right, so I'm going to write something on the side right here. So whenever I teach, I always try to put the little principles on the side. You see like how you see direct variation over there in the yellow? So I'm going to write something else right here. All right, so look at this. Oh, I think the hole on the font is a bit too big. Let's turn down the font. All right, so whenever answering one of these questions, always, and people don't worry about the spelling right now. Always try to find the value of the constant k. And that's it. Don't worry about the spelling right now. That's basically what it is. All right. So you see, whenever you give one of these questions right here, one of the key things that you need to know is that you're always going to have to figure out the value of the constant k. All right. So can somebody tell me here, based on what we have, do we know what k is? All right. Did they tell us what k is? Did they give us what k is? So did they give us what k is right here? No. All right. So what did they give to us? So let's plug what they gave to us into the formula here now. Different color. So if we plug what they give to us into the formula, what is the distance? Right. We can see that the distance is 40. And that's equal to, we don't know what k is. So let k stay short it there. But what is the speed? The speed is 70. But don't just write the 17. I remember that you have to put that in the brackets because this is multiplication. And they remember that you have to square that. All right. And when I look in the YouTube chat here, I see some people with that right there. Right, but I see somebody write 70 equals 40 squared. Remember, the question says a speed of 70 and s is speed, so the 70 has to be here, a distance of 40, so the 40 has to be right here. All right. So remember, we said that we have to figure out what the value of the k is based on this formula. Right, we should now be able to figure out what k is because this is an equation. And once you have an equation, all you do is that you try to get the value of the variable or the constant, the unknown, I should say, by itself. All right, so let's work this out here. So 40 is equal to k times, remember that you're going to square first, you know? So 70 squared, 4,900. And then I want to figure out k, so I'm going to divide both sides by 4,900. That is going to cancel. K is equal to, and then I try to work this out a bit here. 2 into that is 245. So 2 over 245. That is the constant that we got for k right here. All right, and again, direct variation. So you always start with this formula and then based on what the question gives. So you see what you do after that. So all you do start with the formula. Start with the normal formula, everything good. But then what you do after that now is based on exactly what the question gives to you. And the question told us speed of 70. So 70 has to come here. Distance of 40. 40 has to come there. And then you just work it out based on whatever we're going to have to do right here. All right. So remember now, we have still not finished the question because what the question is asking us for is what distance. I remember distance is d. What distance is required to stop a car traveling at 80 kilometers per hour. All right, so let's see if we can figure that out now. Again, let's start back with our formula again. Let's work out the second part of the question here. So using the same formula, y is equal to kx. But what we actually used is d is equal to ks squared. Remember, we now know what k is. When we go to the question, they gave us what s, the speed, is. What they now want us to do is to figure out d, the distance, and based on our same formula here, we should be able to do that. So d is equal to k is 2 over 245 times s squared. The speed is 80, so 80 squared. And then we just try our best to see how we can work that out and get the answer for this right here. All right, so d is equal to 2 over 245 times, and of course you know that you have to square that first. And then can somebody work that out and tell me what did we get for our answer? When we plug this into the calculator, what are we going to get for our answer? So multiply your 2 times your 6,400, then you divide all of that by your 245. What are we getting?
Some folks work it out.
Sir, I got 52.24.
52.24.
Yes, sir.
Let's check that. All right, let me do something here. Let me start. I'm gonna share something different. Hold on, let me share the screen itself. All right. So you should now be able to see this calculator. Can we see this calculator? I hope we can. We should be able to. You see that, Mr. Bernard? See the calculator there?
Yeah, man, I'm seeing the calculator, yes.
All right, so look at what we have right here. So we have 2 over 245 times 6,400. So I'm just showing you on the calculator how we can work this out, right? So remember that you're going to multiply the numerators first, then divide that answer by the denominator. So once you have a scientific calculator, multiplying the numerators first, we just put them in brackets. And so the calculator is going to know that it's supposed to multiply the numerators first, then divide the answer by 245. Let us now press our equal sign and let us see what are we getting for our answer here. Our answer right there, they give us that this was a fraction. We press that and that button right there, and there's our answer, 52.244. They did not give us any one decimal place, any approximation, so I'll leave my answer as 52.244. Let's say 2 decimal places. That would be 52.24. And so that's how you work out any question that is talking about direct variation. So you start with a formula. That's a formula right there. And then based on what the question gives to you, you then edit the formula now to put in the variables that you're given. And then you just work out the question based on what you get. All right. But remember the key thing, whenever answering one of these, what you always have to do, always try to find the value of the constant K. Right, so always try to find the value of the constant K.
Before we move on, Mr. Foster.
Yes, sir.
Let them know the other principle, because the exam might not give them direct variation, it might give them inverse variation.
All right, indirect variation. All right. All right. And I don't know why my font is so large. But indirect variation. All right, so whenever if they give you a question based on indirect variation, this is the formula that we use. Y is equal to K over X. And so everything that we said from before, everything remains the same. The only difference is just that you're using a different variation to the formula right here. All right, so if it's direct variation, Y is equal to Kx. If it's indirect variation, Y is equal to K over X.
Yes. Before we go further, and also students, just as how they use varies directly, to identify if it is indirect variation, they're going to tell the varies inversely, indirectly or inversely. All right, so look out for the terms used, the words used. The words used will assist you. All right. All right,
so look at this right here. So I just make up something. So don't worry about this. I'm just making up a question here, people. So based on indirect variation, let's just do something right here, right? So it starts by saying if n varies indirectly or inversely to the square root of b. All right. Or not if n, but it's going to say n. So n varies indirectly or inversely to the square root of b. Bam. All right, let's see here now. So n is equal, and again, people, we're just making up a question here. N is equal to 40 when b is equal to 35. Let's just say 35. All right. Determine that is determine the value of B when n is equal to 100 for, let's say, two significant figures. All right, people, so write that question down for me here. How would you approach that? Based on what we did for the question from before, and then based on what I said is the formula now, how would you do this one? What did I just do? All right, so firstly, can anybody tell me what is the equation that you're going to use? So this is the equation for indirect variation, but based on what the question gives to us, what would you then write for your thing? What would you do? Right, so n varies indirectly or inversely to the square root of b. What is the equation that you would write based on that? To start off the question. Because remember, you always have to start with the equation there. All right. Let's see. So let's see if we are all thinking the same way here. So in the question above, it says d varies directly as the square of the speed s, and when we were writing our equation, we used the d as the subject. So if they say n varies indirectly or inversely to the square root of b, I am guessing here that we're going to be using our n as the subject as well. So n is equal to, remember, it is indirect variation, so this is the formula that we have in our mind. So why we're substituting that for n, we always need to have our constant in this case, you know, that is our k, and then over b. And I hope that that is the formula that we were thinking of. That's the formula that we had. So n is equal to k over b. Now let's try to figure this out. So the first thing you always do, always try to find the size or the value, sorry, of the constant k. And so the question says n is equal to 40. So n is 40 when b is equal to 35. So hold on, this is the square root of b. The square root of b. And again, people, we just made up this question here just to show you something, how you can use this formula. So again, find the value of k. So in this case, we're going to cross multiply. And so 40 multiplied by the square root of 35, that is equal to k. So are we getting for the answer right here? Let's check that. So 40 times the square root of 35, press our magic button, 236.64. So let's write that one, 236.64. So that's the value of k, 236.64. And let's just try to finish it down here in this little space that we have down here. So the space down here. They now say determine the value of b when n is equal to 100 to two significant figures. So again, start with the same formula. N is equal to k over the square root of b. They now want us to figure out the value of b when n is equal to 100. So n is 100. We know that k is about 236.64, and you're going to put that over your b. All right, so again, whatever you do in your question depends on what the question gives to you. So in this case, you want to find b, we're going to cross multiply. So b times 100 is equal to 236.64, and then to get our b, we're going to divide both sides by 100. So in a case like this, b would be 2.3664. But remember, the question says two significant figures, so the answer would actually be 2.4. All right, and as I said, what you do depends on what the question gives to you. All right, so that's just an example of how we can utilize our indirect variation there. So quickly again, direct variation, y equals kx. Indirect variation, y is equal to k over x.
Right.
Uh-huh.
All right, so let's move on to question number 3. You can continue sharing the screen, Mr. Foster.
Yeah, man, no problem.
All right, can somebody volunteer to read that question for me, please? 3 part A. Can somebody volunteer to read that question for us, please?
The diagram below shows two pentagons, P and Q, drawn on a grid made up of squares. Select the correct word from the following list to complete the statement below.
Okay. This is a diagram. What does the word pentagon mean? In that case, zoom it in faster. Zoom it in. First, yeah. What does the word pentagon mean in that case? What's a pentagon?
That's 5 sides.
That's 5 sides. Very good. All right. Now, I want you to look good at that pentagon. What you observe about the pentagon?
The same thing, but only thing them in a different position.
All right, same thing, but in a different position. Okay, all right. Now it says select the correct word from the following list to complete the statement below. So make note of those words. The pentagon P is dash, the pentagon Q. Now that's an easy 1-mark question. And when you come on to a question like this, you can use a method called elimination method. So my question to the class, is that opposite to? Is pentagon P opposite to pentagon Q? Is it opposite?
No, sir. No, sir.
How you know it's not opposite to it?
Because it looked like the same thing, and it turned the P turned different.
P turned different. Okay.
Thank you.
So is there a reflection?
Could be.
No, sir. No.
It's a could be.
Looks like
Hold on, Mr. Bernmark. Hold on, let me ask a question. So if so sir asks if it's a reflection. So I'm gonna ask a follow-up question to this. You said that I'm not looking at, let me look at the names. I don't know which was it Tangini who said that they look the same, but then one of them just turned different. There, so I'm not sure who said that, but remember you said that they basically look exactly the same. What is the only difference between them that one of them turned different? All right, so a reflection. When you reflect something, when you looking at the mirror, your face turn different. Me just want to know that. I mean, no. As in, no. Really? Oh, so you're hold on. So your eyes. So remember, so picture the way how your face is on your head. Are you trying to tell me that your head, does your head rotate some sort of degrees?
No.
No, so I'm just asking you because you were saying it might be a reflection, so I was just asking a question. So I guess I can ask them if it is a reflection. Again, they probably can give a different answer.
No, it is not a reflection.
Okay. Yeah, sure.
Yes, sir.
Yes, sir.
Right.
No reflection.
Okay. I am seeing Sir Quinn saying it's not a reflection either. and it says the same shape and size. Now, there's two. What are? Let us pause on the reflection. Well, Lexi said to her, it is translation. You sure it's translation, Lexi?
Sir, feel so. Yes, sir.
You feel so?
You feel sorry, you know, so which one of them? Because the exam are Wednesday.
Exactly.
You can't tell me say you feel so at the exam. You feel sorry, you know.
Have
So
to
what's a
know.
translation? What is a
Have to
translation?
know.
The thing is this, you know, what translation do? Yeah, like what reflection do? That's the key thing here. So hold on, Mr. Burnham. Sorry for interjecting, but let me just do concept. Yes. So look at this picture right here, right? So let's just say that this is our axis right here, right? So this is our diagram.
All right, go ahead.
And that's our diagram, right? So you know, this is the y-axis. Yeah, you know, this is the x-axis. Usually the two easiest forms of reflection is reflection across the x-axis, reflection across the y-axis, right? So if this is about 1 centimeter away, the image point is also going to be 1 centimeter away, right? And it's going to be like this. All right. If we reflect this across the y-axis, it's going to basically look like that. All right. If we talk about a translation now quickly, right? So when you translate it, it probably can go something like this, meaning that it probably can end up even right here, basically like even right here. All right. The key thing that I want you to realize about both of these two things, right? Both of these two things is that there is not really any sort of rotation happening right here. There's a movement in the location, yes, right, but there's no sort of rotation. And when you look at what you have right here, the key thing that you realize is that your shape is basically rotated. Because if I start right here and I just simply rotate this like so, that is going to be right here. If I rotate this like so, this is going to be like here. So that's something like this. If I rotate this is going to be somewhere like right there. This is going to be somewhere like right here. And obviously this is not 100% perfect.
So question. I have a question to ask. No, all right. We see Sharona Smith saying congruent. Owen say thinks it's congruent and
I change my answer. I agree with them.
you agree with who? You agree with the person congruent?
Yes, sir. After I know the meaning, then I agree with them.
Yes, smart.
Somebody said yeah, which translation?
But beg your pardon though. Beg your pardon though. There are different lines of reflection. Please bear that in mind. Let me ask the class a question. What is the trick method that I advise you to use to know if something is in a reflection, and if it is, to know the line of reflection? What's the trick method I tell you to use?
Use a geometry set to reflect it.
Use a geometry set. Good. So I would play smart and find and place my geometry set somewhere there between and see if it will reflect and turn the other way. Because sometimes if you have y equal x, Mr. Foster, it can turn, right? Look like it turn, right?
Because that would be like a that would be like a rotation basically.
Yes.
Like that.
Yes. So if it all depends. It all depends as well, right? So the line y equal x. The line y equal x or the line equal remember we have y equal x and
Y equal negative x.
Y equal negative x. It can be a possibility that it's a reflection but looks like a rotation. Can be a possibility. And please do remember that in a transformation geometry, the images, the figures used to transform are always congruent. They're always the same shape and the same size. So your answer may not be congruent. Where I'm coming from? The answer may not be congruent.
Why not, sir?
Why? But I just explained to you. What does congruent mean? What does congruent mean? What does congruent mean? Tell me what congruent means. What does it mean?
So it's like when the thing is exactly the same, but it rotates.
Exactly the same, but it rotates. You sure that's what they want to say? You sure that's what they want to say?
The same shape and the same size.
Yeah, but as I'm saying before, in transformation geometry, they're always the same shape and the same size. They never change. Never change. So how we work with that? How we work with that? All right. Let's say we can find something here, right? Let's say we can find something. Let's say we can find something here. You ready now? All right. First, I'm gonna share my screen a bit here. All right. I'm going to bring up a picture. I want you to focus on this picture. Everybody seen this picture here? That's actually a video. Hold on.
For just $67, you can make as many videos as you want, and you never need to pick up a camera.
Can everybody see this picture right as I'm showing you?
Can see clearly.
All right, good. Now, note that this is the image. This is the actual figure. And this is the image itself. Now, question. Don't both triangles look congruent here? Are they not the same size and same shape? Are they not the same size and same shape? Yes or no?
Looks to me, sir.
Good.
Yeah.
Yes,
so it's congruent. It's congruent. But look at the orientation now. When it is reflected on the line y equal x, what you notice happen? Looks like it rotates, don't it? Right? So you have to be careful of the response that you get. Now, those two responses can arguably be correct, because it is congruent by definition, the same size and the same shape. Good, but I would go with the answer of reflection and not congruent. What say you, Mr. Foster?
In a situation like this, where you face that question, where you realize that there are two answers that basically two answers that basically are correct. Basically, you go with the one that is, let's say, more correct. So it's not that they are not congruent in a way. You see, because the location change and reflection kind of have to do with more have to do with changing the location from somewhere to somewhere else. Then I would more to choose reflection than congruent, because congruent really have to do with location. It just have to do with the shape and the size.
Exactly.
So they have the same shape and size, yes, but you also have to factor in now the fact that the location has changed.
Good. So transformation
Sir,
took place. Yeah, go ahead, Lexi.
sir, but if I wouldn't it be like it would occur if a reflection.
Come again?
Right
Is it
now,
would be
my
what?
brain just gone because when you said this, I answer. When you said this, I answer.
Now hold on, hold on, hold on.
No,
I am
we never say
we
what
never
is
give you
answer,
answer
what is answer.
before.
We just discussing.
We ask you a question, but remember, you know, there's a maths principle. Hold on, I'm trying to get the picture bigger. There's a maths principle, right? There's a maths principle that tells you that you must be able to critique your colleagues or your classmates' responses. Good. You must be able to critique it. So you guys have said what we have done first is to utilize what we call the elimination method. Right? We utilize the elimination method. That's what we did first. Good. But note, so we know it's not opposite. We know it's not translation, because with translation, the orientation of the object doesn't change. Doesn't change at all. It doesn't change at all. But so it could not be translated. So you are left with two options to choose from: congruent and reflection. The both of them are congruent, but Mr. Foster, go back to the question for me, please. Let me show them something. Go back to the question, Foster. No, the pentagon P is dash to the pentagon Q. Now, they have given you a clue as to how to answer the question. Now, the two answers can be correct, you know. But what is going to lead you now to the correct response is how the sentence is structured. Now, pentagon P is reflected to pentagon Q. No, that doesn't sound like it makes sense. But if it's a pentagon P is congruent to pentagon Q, then you get your answer. So we'll go by based on how the sentence is structured in the response. I'd go congruent right there. So you understand, Foster?
I understand. At the same time, I would still go. I also have notes to go with reflection as well because of the change. Because of the change of the orientation.
Yes,
for me,
it's funny.
This question is not a, this question is an open-ended question. You see questions like these. You see questions like these when the examiners mark these questions, what they do is that they just give you the answer for both of them. Because it can be critiqued both ways.
So here's the punchline now. Here's the punchline. Part 2 is the punchline now. They ask you now to give a reason.
And then that is where you get your mark for the first part.
Exactly.
If you say it's a reflection, you have to state some reason why. If you say it's congruent, you have to state some reason why. And then the reason that you give now, that is what now is it. We'll let them say, all right, yeah, man, them know what they must say, and I guess that one.
Exactly. So we're showing. Hold on. We could take them back now, faster. Because we don't want Daniel to go on to the sea and drown, right, Daniel? Right, Daniel?
Sir, I'm doing casting already, so you can imagine.
We're going to put in the lifeguard now. We are saying to you that both responses are correct, but whichever one you choose, you must give your reason for. You understand? So if you choose congruent, you're going to easily say yes, because both of them have the same size and shape. So that will be correct. Naturally correct by definition. If you choose reflected now, you have to state the line of reflection that shows the reflection itself or creates that reflection. Good. So whichever answer that you choose, it will be correct. However, you must give
whichever one is easier for you to explain.
That's why they ask the reason for choice.
Yes, that's
yeah.
why
So and so you have to just make sure so whichever one is easier for you to explain, just stick to that.
All right. So, Mr. Foster going reflection still, but we're not saying no to congruent. All right.
Just make sure that you have your correct reason.
Correct reason. All right. Move on to the next question, Mr. Foster. Yeah, that's a congruent. All right. That's where we are. All right. A volunteer, read that question, please.
The diagram below, not drawn to scale, shows the pentagon VWXYZ. In the pentagon, YZ is parallel to XW and YX is parallel to VW. Angle XYZ equal 114 degrees, while angle VZY equal to 98 degrees.
All right, hold on, Pastor. Don't get the principle yet. Don't get the principle yet. Don't get that yet. Question to the class. Don't get them it yet, man. Question to the class. If you're in the exam, what was my instruction to you to do the question like this to get the answers easy? Okay, what is it, Devon?
Use the protractor.
Use a protractor to do what?
Find the angle, but I'm also.
But before you use a protractor, you have to do something first.
You have to draw the exact
draw the exact thing using the angles given, and of course that's where the protractor comes in. Draw the exact thing using the exact angles that is given. Understand? No. So if you draw the exact thing with the angles given, then by no means you should be able to calculate or to determine the value of each of those angles. Now, before Mr. Foster give you the principle, I'm going to ask you a question. I want all of you to draw a rectangle. Draw a rectangle in your notebook quickly. And tell me what is the sum. So draw a rectangle quickly. Draw a rectangle. Sketch one rectangle first off. All right. So we have our rectangle. Now, what's the angle of the tell me what's the size of the interior angles? The lower left and the lower right. What's the size of the interior angles? Somebody unmute your mic and answer. Based on the rectangle that Mr. Foster just drew a while ago. We see round avocado using a principle co-interior angles. Okay. Could you share what you mean by co-interior angles, round avocado? Yes, but back into Zoom. What's the size of the angles on the inside of that rectangle? Come on, students. Look at the thing I'm telling you.
Sure, 90 degrees.
90 degrees. So my question now, put on the parallel lines and parallel. Yeah, put in 90 degrees. Yeah. So they are both 90 degrees. Now question, are those two angles formed between two parallel lines? Yes or no?
Sir, repeat.
Are the two angles formed between two parallel lines? Yes or no?
Yes.
Good. And my question to the class, what's the sum of those two angles that form between the two parallel lines? What's the sum again? It says 90. What is the sum? I'm not unmute to the mic and answer, man. What's the sum?
180.
180 degrees. So now it doesn't matter the size of the angles between the parallel lines. So if just in case you forget the principle in the exam, relax your mind, draw a diagram with parallel lines. And the easiest one to look at is your rectangle. So based on the fact that, and you can experiment if you wish, you can draw a parallelogram, measure the angles between the two parallel lines, and add them to see if you get about the same 180. That's why it's called CDP labs, you experiment. So once you experiment with a parallelogram that shapes different from a rectangle, and then you recognize that with the parallelogram, you still have two parallel lines, slant one, because this is a parallelogram too. It's the slant one I'm referring to. Good, one with the acute angle, and the other one with that, what you call it now, obtuse angle. And add the two of them now and see if they still come to 180. You can do that in your own time. But they can have arrived now at the principle and say, but wait, it doesn't matter the orientation. As long as there's two parallel lines, the angles formed between the two parallel lines will add to what? 180 degrees. Correct, Mr. Foster?
Of course.
Very good. So that's what I try to do with them faster. I don't want to get, because I don't must remember the principle. You understand? But you must come up with a method now that they can use to drag your memory or get you to think and come up with the answer. So look at the details. The keywords given in the question, parallel. They are parallel. Good. So once they're parallel, you're going to know exactly where the angles are. As Mr. Foster put it, angles between parallel lines are supplementary, are co-interior angles. Good. Angles between parallel lines are supplementary, which are the same thing as being co-interior angles are supplementary. Well, means add up to 180 degrees. So write down those principles in your notebook, because if you write it, you'll remember it. So then, Ounce was giving his answer, 66 degrees, which is correct.
What?
Yeah, go ahead. Bring back your screen, brother, faster. Screen gone. Thank you. So write that off. So because of that principle now, you can now find the value of x and know that the letter in the middle is what they're referring to. So that's for WXY. WXY, letter in the middle. Good. And it is supplementary to ZYX. Supplementary to ZYX. All right. So question now. They have asked us now for ZVW. ZVW. Now in this case, right? So sir showing you the calculation there. Good. So Ounce, you're very much correct. So in this case now, when sir is finished with that. Oh, you're using the tablet faster.
Yeah, man. Yeah.
No, man. All right. Tablet go on good, brother. Just with tablet go on sweet. All right. So the angle ZVW. Now look where V is. Now I have a question to ask. Students, are you listening?
Yes, sir.
Okay. I have a question to ask now. And here's my magic question. This is my magic question. Now they told you that W and YX are also parallel. Now, if that's be the case, how can we then find the angle of V? Anybody have the angle for V? Those in the chat can give us the angle for V. Owen says for the next one, what else I multiplied 180 by 180x by 3 and got 540. Then I subtracted the 540 by 392 and I got 148. Well, Mr. Owens get 148 degrees. All right, so VW. Look at the angle, location of the angle. How do you work this one out? No, not difficult. Not difficult. Look at it, very good. Look at it. Could we still use the same supplementary angle principle to find V? All right, we hear our dear Devon says 82. Is Devon correct? Devon says 82. Is he correct? Devon says 82. Anybody have a different answer? Devon says 82. Anybody have a different answer from Devon?
No, sir.
What answer you have?
82.
You have 82 as well?
Yes, sir.
All right. Okay. All right. Well, it's not 82 at all. It's not 82 at all. But if you use a header now, if you use a header now, if you use a header, you can find V easily. I want you to look good at the shape. I want you to look good at the shape. Where the angle X is formed and where the angle W is formed. Isn't it also, isn't the angle at W supplementary to the angle at X? Yes or no? Huh? I'm not hearing you. I'm not hearing you. Isn't it supplementary?
Yeah, no. Really?
What would make it supplementary, by the way? What would make it supplementary? The note is in front of you, know. The note is in front of you. Angles between parallel lines are supplementary.
You call them parallel?
Then WV and YX are parallel, people?
Yeah.
So therefore, 68 plus what give you 180 because W and X is supplementary as well.
What plus what?
W and X is supplementary.
68, 66.
66.
114.
Oh, exactly. 114. So they only have one angle to find. You don't only have one angle to find. You see now? So you have to use your eyes, students. Look at the question. Be observant. Good? Be observant. So therefore, that is W now. But they ask us now to find V. So what would you do now to find V? And Mr. Ounce, you did very good. Job well done, but I don't think it's 148. Or it will be 148 because I think I added the wrong number there. Yes, talk to me now, students. What would you do now after finding W? You have learned to go around it, you know. You have to learn to go around it. You have to learn to go around it. Nobody? Nobody? Yes, it's 148. That's correct, Mr. O. Job well done. All you gotta do, students, the total angle inside of a pentagon, as sir is writing there. The sum of the interior angles of a pentagon is 540 degrees. 540 degrees. So if you know 4, you just add up the 4 minus it from the total to find the fifth one. Nice try, Devon, and everybody who's tried. Nice try. Good. Good. All right. So technically, and you have a formula there, sir, showing you. What's that? 100 or 180? Okay, to find the sum of the interior angles, you can use that formula, 180 bracket n minus 2. All right. Now, so you have the notes, but always remember as well that you draw the thing to scale. Draw it to scale. If you draw it to scale, everything will come full circle. Cool? Cool? Hello? Students?
Oh, yeah.
Answer the man.
Yes,
Answer the
sir.
man. Answer the man. Answer the man. All right, Mr.
Can you
Foster.
hear me?
Yeah, me hear you now.
Okay.
All right. Good. So you can screenshot the notes that Mr. Foster writes in there and make sure you know it, and you can prove it to yourself as well, drawing the thing. You must experiment with these things, students, and prove the theory is correct so that when you go into the exam, you can just draw and refigure out the theorem so you can use the theorem. All right? All right. All right. All right, so Mr. Foster showing you the calculation. So the 140 degrees. And once again, congratulations to Ounce. I think Ounce is from St. Vincent. Don't kill me on that one. I think that Ounce is again from no, Ounce is from St. Kitts and Nevis, and Ruben is from St. Vincent. All right, now zoom in, Mr. Foster, zoom in. All right. Now, we're going to look at the question now. Carry to the top, Mr. Anything at the top? And then where to the top? Reduce a bit, reduce a bit. All right. Can somebody read what's at the top, please? Bring about the shape. So, yeah, good. Can somebody read what's at the top, please?
The letter A and the point C, 6, the position vector 6 are shown on the grid below.
Okay. So I said the point C shown on the grid below. Now, Question. Read what's at the bottom there.
On the diagram, draw accurately each of the following transformations: the enlargement of letter A by scale, 2 about center, C 6 the translation of letter A using the vector T
All right,
equals
so what do you part by part? What do you like part by part? Now, my question now, I believe I've done something like this before. They gave you the scale factor too, and they also give you they also gave us the center of enlargement. Now, what can you do with the scale factor? How do we use the scale factor? How do we use the scale factor?
So, okay.
How do we use the scale factor?
Multiply it by the column ATC.
What do you mean? Multiply by what?
So that the scale factor is yeah, man.
So you know what it's telling me, sir? When you come on class, and that's it. And is it, why students don't do as well as they could? No, don't draw that man factor. Don't draw that man. Don't draw that. Don't draw that. That them have to learn, you know. Listen now. I'm telling you something. It's when you come on my class, or in my teacher class, it's not an entertainment business, you know. Set me as supposed to go back and do questions for yourself. So you can learn. The learning begins when you start to do it. Now listen to me now. If what give me one of the coordinates for the letter A. Give me one of the coordinates then. Give me one of the coordinates. Somebody give me one of the coordinates for letter A.
3, 2.
3, 2. What can you do now with the scale factor?
Multiply it by that coordinate.
Then let's tell me. And what's that new card? What's that new coordinate now?
Sorry,
What will be the new coordinate? When I multiply with the scale factor.
6, 4.
Plot that point for me faster. 6, 4. All right. So give me a next coordinate. Come stop with somebody unmute your mic and answer, man.
4, 4.
4, 4. And what's the new coordinate?
8, 8.
Plot 8, 8 from faster. I kind of far out still. 8, 8 they're gonna far out. So you can plot it, push it up somewhere. So. Put that up. So kind of difficult. So. Not now go work faster. All right.
Hold on, Mr. Bernard. Remember that for this one here, you have to, the center of enlargement is not the origin. It is this.
Yeah, man.
So it is different.
Oh, yes, I can't use the scale.
You can't multiply it by the 2.
Yeah, the carry the scale factor. Yeah, right.
So yeah, after this, that's the reason why the question said draw accurately, because it is now. Draw a line. So you're gonna draw a line from the center to through each of the points. So that's basically how you do.
Yeah, thank you for showing that part.
Yeah, and this is the reason why you have to have a geometry set in the exam, because there are times where you have to do things like these. Right, so let me try to zoom in a bit. All right, so the thing is this now. You see, if they say that the center of enlargement is the origin, then whenever you are doing enlargement, all you can do is just to multiply by whatever scale factor they give to you. But if the center of enlargement is not the origin, then the easiest way to get it is to actually draw lines. So use a ruler, and wherever the center of enlargement is, in this case, the center of enlargement is 6, 6. You draw a line from the center of enlargement through each of the points. All right, so through each of the points then. And then what you would do is that you would measure. So using a ruler, you would measure the distance from the center of enlargement to each point, and then multiply that distance by the 2, and then you mark off that distance on the line using your ruler.
Everybody understand that?
No, sir.
Start back over for them faster.
All right, so let me clear out this other one here. Let's just start with one of the points. All right, so let's see, we're using that point here.
Use the Pythagoras theorem. All right. I'll work on the length. Use the Pythagoras theorem, I'll work on the length. You have a ruler upon it? You have a ruler?
I can get a straight line. Hold on. So let me use a broken line. All right, so you can complete a triangle, or if I use a broken line, let's see. So we can complete a triangle right here. When we complete the triangle, what we're going to get is that we're going to find ourselves with a right angle triangle. All right, so we're going to find ourselves with a right angle triangle, and then you can use your Pythagoras theorem and work out the answer. You can actually even use the ruler itself and just measure the distance here. Right, so you can physically use the ruler, measure the distance here. They multiply it by the 2, and then you extend your distance.
All right, so to show them now where after the multiply the distance by the 2, show them where now. Where does it start that new line now? When it's multiplied by 2. All right, say that was 4. So that length was 4 centimeters.
Oh, sorry. So say that this was 4 centimeters.
Yes.
All right. Then what you do is that you start from the center of enlargement itself.
I measure.
And then you measure the 8 from there. So don't come right here and measure the 8 from there. No. All right. You go back to the center of enlargement and you measure the 8 from there. Right. And we're just saying. So say that this was 4. You start right here, the center of enlargement, and then you measure off 8, and the 8 is actually going to bring you right here. This is the actual point right here. All right, so I'm not sure if this. I'm not going to write 4 here because I don't remember exactly what the length is, but I know for a fact that this is going to be the point.
No man, I want them to understand. I want them to understand that in the exam, because when they tell them to draw the line, they might end up drawing that line from the point where you show them not to draw it from.
Yeah, man, which is right.
Good. So I want them to understand that when you measure the length from the center of enlargement to that point there and you multiply it by 2, You start back at the center of enlargement and measure.
And then you measure off again down to where to yeah, double it right there.
Everybody understand that? Everybody understand that now?
Sir, can you
Let's say that this is
Wait,
point to y.
Hold on, faster. Tangini, never hear. You weren't following what we said, Tangini?
Sir, what you said about doubling the fine, something like that.
No, what we're saying, what Mr. Foster is saying, first thing you do is to draw a line where the center of enlargement, which is right there, to one of the points. It could be any point, it doesn't matter which point, with one of the points.
Hold on. Remember, so hold on. So I don't know if you're not remembering this. So remember, it says the enlargement of letter A by scale factor 2 about center. So the question tells you that the center enlargement is C. That is the reason why we start at the C, and the first thing I did is to draw a line from C through one of the points them are A. So I never have to use this. We could have started a C and draw a line through this point here. And we could have started a C, draw a line through this, or draw a line through that. So or draw a line through that. So it doesn't matter which of the points I go, because I think for the question you had to draw the line through every single one of them. All right, you'd have to do it for every single one of them. But I'm just explaining it with this one right here.
Just use
right?
one.
Right. So you draw from the center of enlargement through the points, and you see after you do that now, then you use a ruler and you measure the physical distance there. I remember that a geometry set is required in the exam. All right, so you have your geometry set, you take out your little ruler, you measure your line. So this line that I'm drawing in blue right here, this you measure that. All right, so you measure that. All right, and you see after you measure that, you come back a C. Go back to C, and suppose when you measure that blue line, you get, let's say 5, right? Remember, you get 5, you get 5, but remember that the scale factor is what, 2. So the first thing you do know is that anything at all you get for the length. So
for the 5 years, for the 5.
Yeah, that's what I'm going to do. So let's say you get 5, all right? So it's a scale factor. So it's a scale factor multiplied by the length equals, and this is not an actual, I'm just writing, this is not an actual equation, right? Or actual formula. So, right, but basically, if you know the scale factor and you know the length from the center to the original, this is the original point, then that is going to be equal to the length of the image, which means the center to wherever the image is. And as I say, in this case, it's right here.
Hold on, faster. Hold on, one second. No, students, pay attention. From the point 66 to the point 52, where it's not drawn the scale, we're assuming that it's 5. You get that, Tangini?
Yes, sir.
I will get that 5 by measuring that length with a ruler. You get that too?
Yes, sir.
Nobody mute your mic. Wait the whole day if you're unmuted. So keep it unmuted. No. So once you measure that now, the scale factor is 2. So whatever scale factor them give you, you're going to multiply that length, which is the 5, by the scale factor. So in this case, the scale factor is 2. Now 2 times 5 is what, Tangini?
10.
So you're going to put your ruler, starting the 0 on the ruler at 66, and measure along that line till you reach 10. So the full line now, you know. Draw a curve, embrace. There's no something I mentioned the full line. Let's draw embrace. Draw embrace. On the other side. Left side. The other side. Go towards right. Yeah, let's draw embrace. No, not for the line. Alright, I'm sure.
Hold on, draw what?
Brace, man. Let me show you. Brace, man.
Yeah.
So from here to here. Is that Tangini?
Sir, I'm not seeing.
Oh,
You're
that's
not
it.
seeing it. Tangini, see it now?
Yes, sir.
Good. So we're saying from here to here now would measure 10. You follow now?
Yes, sir.
Good. So you don't start the measurement from here. You start the measurement from here again. So from here to here must be 10. Good?
Yes,
Or
sir.
you could also start from here to here. It must be the same what? 5.
Yes, sir.
You follow now?
Yes, sir.
So after you do that now, you repeat the same steps with all the other points them that form the shape. Is that clear to everyone now?
Yes, sir.
Alright. Alright, first. Next part of the question.
Yeah, all right. So that's how you would do that to get the answer for that one. Clear that slip the grid.
Clear. Okay, hold on.
Then the next part now says the translation of letter A using the vector t equals -3 and 2. You see, for this one, there are two ways that you can get for this one.
Wait. Don't tell them what it means. Hold on, man. Hold on. They were told this before. What does that T tell us? What does the translation vector tell us? How do we use the translation vector? Anybody? How do we use the translation vector? You were told this last week, you know. With the mic faster. How do we use the translation vector? We'll wrap it up now, and tomorrow we move on to the next question. Starting at 5 o'clock, 4 o'clock, 4 or 5 o'clock, one of them times. How do? Is it done here?
5 o'clock.
5 o'clock. How do we use the translation vector? Anybody? What do you remember?
So I'm gonna try. I think it's that you turn the thing into a column vector, then you add it to the
Listen, how do you use the translation vector? See it in front of you there. How you use it? Translation vector. How do we use
you move
Yes, you move.
Move
Yeah,
the
go ahead
figures.
now.
you would move
Move the figures, yeah.
that would be 3 units to the left.
To the left, and then
2 units up.
up. Exactly. Lexi, don't go to my exam, go dash my marks, please. Anytime in the exam, remember Mr. Bernard that shout at you. Remember Mr. Bernard that conk in your head. Don't go in there but lose the marks. Do you understand that? You know what to do. Be confident. Read the question slowly like a snail. Then apply yourself. All right. Good. And actually, good. So Mr. Foster is telling you, positive means to the right, negative means to the left, and then on the Y, positive up, negative down. All right. Good. So once you know to use the translation vector, what Sir Foster is trying to instill in you guys is the principles. So there's two ways to look at this thing. You know the principles, you apply the principles. But before you can apply it, you must read to ensure to find out which principle is applicable to the question. Is that clear? Is that clear, students?
Yes, sir.
Or the other way around, if you fail to remember the principles, then if you're not practicing to use the principles in that time, you're running yourself in trouble. God, and a drawing this right now. You have to know how to use what is given. All right. Enlargement, rotation, reflection. Them a question lose and translate lose marks one. Right. You can write down those principles. Preferable screenshot them. All right. The hours upon us now. Bedtime phone now. I'm gonna go on bed no later than 10 o'clock. So what question is that now? What the faster? What number question is that? So this should have been completed. Let's yeah, you can scroll on.
Question 3.
Question 3. Scroll on. Scroll on. All
Oh,
right. So
that's
tomorrow,
finished now.
yeah. So tomorrow we'll be starting from question number 4. And students, listen to me. Mute the mic, Pastor. Question number 4. We'll start at question number 4. Right? And you have received, I have sent you the document. So if you reach home before 5 o'clock, go through question number 4 to the end, have your answers ready, and me I beg you to don't come to the class, come waste time. Because we're not done late tomorrow, we're done early tomorrow, so you get enough rest. You understand? So you must try the questions them for yourself first. That's a must.
By the way, Mr. Birdman.
Yes.
I'm streaming tomorrow on YouTube, you know. So I don't know if you want us to collaborate and do. So
no
we can
problem,
talk about that.
No problem, because I'm not streaming, so we can join you.
You know, we can talk. Yeah, that is right. So that's all the students that I have lined up and everybody, so we can have a nice little final session tomorrow before the exam.
All right, so all you have to do is send me the link so I can send it to them. So they can have the link, all right?
I'm going to be starting a little bit afterwards, and so you probably can run through the paper with them, because what I'll be doing is I'll be focusing on some circle theorem, some matrices, some essay reflection and those things. I'll be doing matrix transformation though. So the multiplication way of doing it, not when them get the graph, but when them want to use matrices and do it. And I think I might probably look at a few little bearings questions or something like so.
All right, so let me fix it up now. All right, because
what about 6:30?
Yeah, 6:30. So those are on YouTube. All right, Owns, to get the paper. Let me give you the WhatsApp number. Hold on. Mr. Owns, to get the paper. Okay. Now, so students, I will start today at 5 o'clock. And then we're going to join Mr. Foster's stream. We're going to join his Zoom meeting at 6:30. Everybody get that? I'll start with you. So we have 1.5 hours. Good. And those persons who are on YouTube, you look for Edu Plus. You see Mr. Foster's YouTube name in the chat. Edu.
I just sent the link in the chat as well. Yeah.
Okay. You mean our chat?
Yeah. So just subscribe, because I'll be scheduling it. I'll be scheduling it and sending out a reminder. So just look out for it. Accept just set the reminder and get ready, people. So if you know, say the exam is Wednesday, and boy, we still have a couple things to do. Just come tomorrow. We'll just run through as much as we can run through and see how much we can get in before the exam.
Yes.
Because we want our best to go to bed by like 11 o'clock, because we need to get a nice 8-hour sleep.
Exactly.
So if you attack the paper.
All right. So listen up now. You're going to subscribe to Mr. Foster's channel. Those persons who are on YouTube, subscribe to Mr. Foster's channel, which is Edu Plus Brother Foster Tutorials. Write that down. Don't forget it. Subscribe to his channel so that you can catch us live tomorrow night. Good. Weekend bearings on. If you're weekend bearings, make sure you subscribe to Edu Plus Brother Foster Tutorials.
Mr. Owens, make sure you say you subscribe to the channel, man. I'll be doing some bearings tomorrow, Mr. Owens. I'll be doing some bearings tomorrow. And I have some tutorials on the channel as well. So you can check them out as well, you know. So on the channel I have a lot of you're talking about bearings that mean you have a trigonometry problem. Just check the channel, man. Everything to do with trigonometry. I have a live stream there. 2 hour ad, everything on trigonometry. So they can watch, they can check out that before you even come tomorrow, so that you have those principles back in your head and they will just run back through them again tomorrow.
All right, good. And to close off now, students, please ensure you have the document. Tangini and Lexi, you can share it with Daniel and company so that they can share it with each other all over the place. And so Daniel and Devon and those who are here, go through that paper before you come to class 5 o'clock tomorrow. No joke. Go through that document starting at question number 4. Have your answers written down. So all you should be doing is coming to check to see if your answer was right or wrong. Everybody understand that?
Yes, sir.
Does it make sense to you?
Yes, sir.
All right. Good. So Mr. Owens, just subscribe, Mr. Foster. Just subscribe. Mr. Owens is a visitor from
thank you, Mr. Owens.
From St. Vincent, from St. Kitts and the Navy.
St. Kitts.
And Ruben is from St. Vincent. So we're closing
to have
off
you guys here, you know?
Yes, man. So we're closing off now. And we want to say a special thanks to our Caribbean nationals who have visited the YouTube channel. And remember to subscribe to Mr. Foster's channel, Edu Plus Brother Foster. We saw Indra Plumber as well. Good night to you, Indra. All the best in the English language exam tomorrow. And we saw Round Avocado. Thank you for participating as well. And I think Ruben subscribed as well. All right. So Ruben says, good luck on exam, guys. All right. And we're seeing also Captain as well, Sharona Smith as well. Thank you for participating, Sharona. And all the other participants who have participated in this. Remember to subscribe as well to Mr. Foster's channel. That is Edu Plus Brother Foster Tutorials. And I want to say again a special thanks to you again, Mr. Foster, for jumping on.
Yeah, man, anytime. Boy, I want to say, boy, I was about to take a shower to go to bed, you know, and because I have a couple of videos that I need to edit tonight to put up on thing for the students and for exam. They get me, but okay. You know, anything at all help the students, you know, it don't really matter. You get me, so exactly. No problem, Mr. Brenner. I'm always ready. I'm always here, and as you can see on the screen, people, what does it say? We're outside putting students first. And this is the thing there. So the thing is here. That's how the thing is, people.
Excellent.
All about helping students. That's how Mr. Bernard and I, that's our thing, our mantra, you know, helping the students.
Very good, very good. All right, so folks, want to wish you a good night. So Mr. Foster, don't leave us yet. Just going to end the stream. All right. Just want to wish you guys a very good night and wish you all the very best in your exams. So as you close off, those on YouTube, those on Zoom, just go on the knees and say a prayer and just ask God to take care of business for you tomorrow. So you can get your good night's rest, drink a lot of water, and all the best tomorrow. You will pass your exams. Just have faith. So have a good night to you all. Good night. Banana mouth again tonight. All right. So, all right. So let me end the stream. End the stream.